two things just happened on internet. You sent an email. Every letter of every word arrived perfectly in the right order. If even one byte had been missing, the email would be broken. You were on Zoom call. Half a second of video disappeared. Nobody cared. The call kept going. If your video had paused to recover that missing half second, everyone would have noticed. Why is one perfectly reliable and other perfectly fine being slightly broken? Because they use two completely different protocols, TCP and UDP, the two opposite ways the internet moves data. In the next 10 minutes, you will learn what each one is, when to use which, and the one question that decides for you instantly. By the end, you will know exactly why your Zoom call doesn't pause when the packets get lost. Let's get into it. Every time data travels across the internet, it travels in small chunks called packets. The rules for how those packets get there, in what order, and what happens when they fail are decided by a transport protocol. There are two main ones, only two that matter for almost everything you will ever build. TCP stands for Transmission Control Protocol. TCP is the careful one. Before it sends anything, it sets up a connection between two computers. Then it sends packets in order, wait for the other side to confirm each one, and retransmit any that get lost. When everything is done, both sides cleanly close the connection. TCP guarantees delivery. UDP stands for User Datagram Protocol. UDP is the fast one. No connection, no confirmation, no retransmit. UDP throws packet onto the network and hope they arrive. If one get lost, it's gone. UDP guarantees speed at the cost of reliability. Same job, moving bytes from point A to point B, two opposite philosophies here. Stick this in your brain forever. TCP is the protocol that cares. UDP is the protocol that's quick. The right one depends on what your app cares about. Here's the analogy that locks this in. Two ways human talk over a wire. A phone call is a TCP. Before you can speak, the line has to connect. The phone rings. The other person picks up. You say hello. They say hello back. You both know the line is good. While you talk, you confirm things constantly. Are you still there? Yeah, I am here. If the line cuts out, you call back. You repeat the part they missed. When you are done, you say goodbye and hang up. Both sides agrees the conversation is over. That's exactly what TCP does. Handshake to start. Confirm every message. Resend what lost. Clean close at the end. A walkie-talkie is UDP. You press the button, you shout something into the air. There is no "is the line connected?" There is no "did you hear me?" You just talk. If the other person didn't catch it, they didn't. Maybe you said something else important by then. You don't stop and reshout the last sentence. You keep going. That's exactly what UDP does. No connection, just packet fired into the network. Some arrive, some don't. The conversation move on. Phone call when you need to be understood. Walkie-talkie when you need to be fast. The choice is never which is better. It's which is right for the moment. There are three reasons every engineer needs to know TCP versus UDP in their bones. Reason 1. Interviews. The moment you say real time in the system design interview, chat, gaming, video, location, tracking, the next question is TCP or UDP. If you can't justify your answer in one sentence, you have already lost ground. This is one of the most common single word follow-ups in networking interviews. Reason 2. Performance debugging. A surprising amount of latency in real system comes from TCP overhead. Handshake, retransmits, ordering. Once you know how TCP works, you can spot when it's the wrong tool, switch to UDP and cut latency dramatically. Reason 3. Modern protocols are built on this distinction. HTTP3 abandons TCP. WebRTC uses UDP for media. Video games use UDP. with custom reliability on top. Once you understand the trade-off, every new protocol you read about clicks into place. Here's where we are going. On the left, TCP. Look how careful it is. Before any data moves, there is a handshake. The sender says sync. The receiver says sync, acknowledge. The sender says acknowledge. 3 messages just to agree the connection exists. Now they can talk. Then data flows in packet, each numbered with a sequence number. The sender ships packet 1. The receiver replies with an acknowledge. The sender ships packet 2, but this time packet 2 gets lost on the network. TCP notices because no acknowledge comes back. So it retransmits. Now the receiver gets it, send acknowledge, and the conversation continue. When they are done, final acknowledgement to close cleanly. Every packet confirmed, lost packet retried, order delivery guaranteed. That's TCP. The cost, every round trip takes real time. On the right, UDP. Look how brutal it is. No handshake. The sender just starts sending. Packet 1, packet 2, packet 3. Packet 3 get lost and UDP doesn't care. Packet 4, packet 5, packet 6 lost. Packet 7. The sender never retried because UDP has no concept of retry. If the application cares, the application has to handle it. UDP just moves byte. Same job, wildly different philosophies. Now the practical question. Which protocol for which app? TCP wins anywhere. Every byte must arrive correctly. Web traffic is TCP. Email is TCP. File transfers are TCP. SSH is TCP. Database connections are TCP. If you are loading a web page and even 1 byte goes missing, the page is broken. Reliability isn't optional. You pay the speed cost. UDP wins anywhere. Speed beats perfection. Video calls are UDP. If a frame is lost, you skip it. Don't pause the call. Online gaming is UDP. Your position right now matters more than where you were 200 milliseconds ago. Live streaming, DNS queries, IoT telemetry, all UDP. The data is short-lived. Buffering is worse than dropping a packet. The one question that decides instantly. Does your app care more about every byte being correct or about being on time? Answer that and you have your protocol. I want to be honest with you about something most courses won't tell you. The good news, the TCP versus UDP decision is one of the cleanest in all the system design. You ask one question, you pick one answer, you are done. No middle ground in most cases. The bad news, defaults can betray you. People reach for TCP because it's safe and pay a huge latency cost in the apps that didn't need that safety. Or they reach for UDP because it's fast and then write 1,000 lines of custom code of re-implementing the TCP reliability badly. Here's the honest truth. Modern framework blur the line. HTTP 3 uses UDP under the hood with reliability bolted on the top. WebRTC uses UDP for media and TCP for signaling. Sometimes the real question isn't use TCP or UDP, it's the use the protocol built on the top of one of them. Know the foundation, the framework are just opinion on top. Even from this one video, you can confidently handle 4 of the most common networking interview questions. Question 1. What is the difference between TCP and UDP? TCP is connection oriented and reliable. It does a handshake, confirm every packet and retransmit losses. UDP is a connectionless and fast. It fires packet and moves on. TCP trades speed for reliability. UDP trades reliability for speed. Question 2. Why does video calling uses UDP? Because in the real-time call, the data has a short shelf life. If a frame from 2 seconds ago is lost, retransmitting it just creates lag. Better to drop the frame and move on. Speed beats perfection. Question 3. Why does loading a web page uses TCP? Because HTML, CSS, JavaScript are not tolerant of missing bytes. A drop packet would corrupt the page. Reliability isn't a feature, it's a requirement here. Question 4. How do you build something real time without losing reliability completely? Use UDP at the bottom for speed. Add your own acknowledgement only for messages that really matter. That's what modern protocol like QUIC and HTTP3 do. Best of both worlds with one trade-off: complexity. The last one will signal you have actually thought about how the internet evolved. Trust me. Before you go, take 30 seconds to log this in. Takeaway 1. TCP is the careful one. Handshake, order packet, acknowledgement, retransmit. Slow but reliable. Use it when every byte matters. Takeaway 2. UDP is the fast one. No connection, no acknowledgement, no retries. Fires packet and hope for the best. Use it when speed matters more than perfect delivery. Takeaway 3. The decider question. Does my app care more about every byte being correct or about being on time? Answer that and you have picked your protocol. In the next video, REST APIs. The most common way modern systems talk to each other. Resources, telnessness, idempotency, and what makes a good API versus a bad one. If this helped you, hit subscribe so you don't miss the next one. The full playlist is linked below. See you in the next video.